Hi dear students, today we are going to take a new topic, chemical reactions and equations. Here we can see the some chemical reactions and some of the equations, balanced equation, that and all we will see here. Some of the examples they have given. See, in the first figure they have given milk, and after that they have given curd. When you leave the milk in the temperature above normal temperature in the surrounding, then it will convert into curd. So that only they have given the sentence, milk is left at room temperature, it will gives curd in the summer. Whenever you have milk, it will be converted into curd when you leave for some hour in the more highest temperature. Then some iron tawa or pan or nail, iron nail is left exposed to humid atmosphere. Means some of the moisture we are living for the moisture means it will convert like this. Means you can see the first diagram and second picture also you can see that it has been rusted. We will tell it is rust. The iron only can make rust. So this is the changes between the metal reacts with moisture. Next we are moving to grapes get fermented. Here grapes get fermented means it will be dry and it will change its shape also. It will fully dried. The water content will be dried, evaporates, that and all we will see here. This is the one of the example. And food is cooked, it will be beginning it is raw material, after that some little bit heats up, it will dry. Then food get digested in our body. Here the food will be taken in the mouth and it will go to the esophagus, means lungs, middle of the lungs, and then goes to the liver and the stomach. Here gastric juice will produce, our food will break to the small particles, minor particles, and the pancreas helps in the proper digestion. In the large intestine and the small intestine, some of the proteins, vitamins, minerals are divided and absorbed in the small intestine and large intestine. Then the we respire. If we are taking inside oxygen, liberation is carbon dioxide. So oxygen is intaking and carbon dioxide is releasing. Here also some chemical process takes place, exchange of chemicals we can see here. Then finally we will tell that some situation, in all the above situation, the nature of independency, in all the above situation, the nature and the identity of the initial substance have somewhat changed. Initial it is one type and final is one type, and whenever a chemical changes occur, we can say that chemical reaction has been takes place. If any chemicals is changed or any chemical is formed anywhere, if any changes happens in the chemicals, means it is known as chemical reactions takes place there. Here for some of the examples we have seen, iron tawa, nail, it will be rusts. So these are all the chemical reactions takes place when it react with moisture. And when chemical reacts, some of the reactions we will get. Here one example is given. See, as we have observed, the magnesium ribbon burns with the dazzling white flame. When we have Bunsen burner, we should have. When we takes the magnesium ribbon, when we takes the magnesium ribbon and using the Bunsen burner, if we heats up or little flames up, it will burns with the dazzling white flame. It will shows the white flame. It is very important, white flame. Then we can tell that the reactions takes place. It is a conversion, it is a changes in the chemicals. Then it changes into the white powder also. After that it will become a white powder. This powder is a magnesium oxide. This powder we will consider as a magnesium oxide. It is formed due to the reactions between the magnesium and oxygen. Here this magnesium oxide as a powder is formed because of the reactions between the magnesium and oxygen. Magnesium and oxygen, this is important. One example you can give means you can write this example. When chemical reactions takes place, I will read the sentence behind that one. From the above three activities, we can say that any of the following observation helps to determine whether a chemical reaction takes place. Above means the iron will be rusted, and some of the chemically reactions we can see. The milk will kept to the highest temperature means it will convert into curd, it will spoil. And some other examples as usual seen in your day-to-day life. If you put lemon inside the milk, it will changes. And when we burn something, we will get carbon dioxide. These are all the things we can tell in the chemical reaction. When chemical reactions takes place, the first point we will see, or some of these five concepts also takes place, or one of them also it will takes place. Change in state. Change in state means it is solid means it will convert as a liquid. When it is solid, then it will convert as a solid to liquid, liquid to gas. This is the formation of this one, change in state. Next, change in color. Some of the reactions takes place in changes in color. Some of them are evolution of a gas. In sometimes the reactions takes place with the evolution of gas. Sometimes change in temperature, automatically temperature will be raised, other automatically temperature will be down. These are all we can see. Then formation of precipitate. Formation of precipitate means some of the liquid, it will be normal in normal temperature and normal things. When we add some of the chemicals, it will precipitate. These are all we will see in this one, chemical reaction. Next, chemical reaction, how it will be explained in change in state. Changes in state. See, first of all, if we take the solid, then if we heats up, it will melt, it will heat. If we give heat or heats up, it will convert into liquid. When liquid heats, it will convert into gas or evaporation. Okay, then another type, when the solid sublimation takes place, then it will converted as a gas. Then gas depositions takes place as a solid. When the gas condensed, gas in the cloudy area and all these things we can see, gas condensed means we will get water. If the water gets heats up, it will evaporate, these things. Once again you see, solid if you melts, it will give liquid. Liquid heats up, it will evaporate as a gas. This is the first thing. Second, we will move when the gas condenses, it will convert as a liquid, and when liquid freezes, we will get solid. Then another thing is that solid sublimation takes place, then it will converted as a gas. Sublimation we will tell when the gas depositions takes, I mean we have to condense that one, we have to give pressure, then it will convert as a solid, gas will convert to solid. I hope you understood this concept, change in state. Next we can further move to change in color. See, some of the fruits at the beginning, this is the one example they are giving. Strawberry at beginning it will be in the green color. When it goes on changing the color, some days color will be changes into the red with pink color mixed, then it will be ready to eat. Then we can't eat the green things, it is not a fruit, it will be raw material of the fruit, we can't eat these things. Next, this is the changes in color. In chemical reaction also, some of the chemicals if we mix together, we will get some different product as color will be changed. That and all you will see in further classes. Next we are coming to evolution of gas. Evolution gas means some of the coal product or some of the materials if you burn with high temperature means we will get some gaseous form. It may be sulfur, nitrogen, oxygen, carbon dioxide, whatever it may be, and as it is in the form of gas. In the factories and all, you see the cloudness of the formation of cloud, like that formation of that gas is known as evolution of gas. It will be evaporated through burning of some of the products or solid, gaseous or liquid form. If you burn with high temperature means we will get gaseous form. Next, coming to the next point, changes in temperature. Here the water will be there. If it heats up, it will convert to the gas or evaporate. But when we temperatures down, temperature if we make the temperature down means we will get into the solid state of ice cube, solid state as ice cube. These things we can see in the change in temperature, and some of the other chemicals also there will be changes in the temperature with their reactants. Next, formation of a color. If any reactants, it will gives the product with color. Any X and Y reactants combines together with a catalyst, it will changes to the product as a product, and it may be having some different color. These are all the characteristics of the reactions takes place. Next we are moving to the valency chart. Here we will tell the valencies. Once I will repeat, study thoroughly, it is important. Here OH means hydroxide. Here all those having valency 1, valency 1. Then chlorine Cl minus, it is known as chloride, then it is having valency 1. Bromide, it is having valency 1. Iodide, nitrite, bicarbonate, aluminate, silver, sodium, hydrogen and potassium, all these things are having valence 1. Valency is 1. Valency 1 means the outermost orbit shell containing 1 valency, 1 gap will be there. Then cadmium having valency of 2, Cd2 plus Ca2 plus cadmium, calcium, Mg2 plus magnesium, Hg2 plus mercury, zinc, barium, oxide, sulfide, chromate, carbonate, sulfate, zincate. These are all having the valency of 2 and these are all having the valency 1. Here 1 and here 2 valencies. And next, copper and iron, both of them having variable valencies. Copper having 1 and 2, iron having 2 and 3. But aluminium Al valency has fixed to 3. Aluminium having fixed of valency 3. Then NH for ammonium, and ammonium is having 1 and lead is having 2. Here you can see ammonium and lead. Ammonium having 1 valency, lead is having 2. Now we can go for chemical equation. What is chemical equation? The word equation means what? A simple representation of chemical reaction in words is called a word equation. A simple representation of a chemical reaction. Any simple representation of chemical reaction. See here, I will take one example. X plus y gives rise to xy. This is one equation. We will consider as a chemical. X is one chemical, y is one chemical. Again the product will get as a chemical only. That is known as chemical reaction. Some of the things, an example they have given, that we will see here. Magnesium reacts with oxygen, we will give magnesium oxide. Here left hand side it is called magnesium plus oxygen, it is called left hand side or reactants. We will call left hand side, these two are called left hand side and these two are called right hand side. Right hand side, this left hand side called reactants. Right hand side called products. In the chemical reaction, these two are very important. In the left hand side we will call LHS. Left hand side it is called reactants. In the right hand side we will tell as product. We should remember this one, very important. A chemical equation can be tell in the shorter hand or shorter method for a chemical change, that is yield we will get. In the left hand side magnesium plus oxides, we will get magnesium oxide. We will get in the left hand side it is called reactants, in the right hand side it is called products. The number of atoms of each element on the both the sides is same, then it is balanced equation. Here you see number of valence 1 mg. Here you will see the magnesium plus oxygen, it gives rise to MgO, magnesium oxide, but it is not balanced. Then we have to balance, then it is called as balanced chemical equation. We have to balance means we will write it as Mg plus O2 gives rise to MgO2. Here O2 is there, then we have to get balanced, then here we have to take 2mg. 2mg is there, 2 2 is 4 we will get. Here we have to cancel each other, which will get right here. The product is 2mgo. This is important equation also, remember it. Next we can move steps involved in writing the chemical equation. The reactants, that is called left hand side, where the reactants are there, that we will tell as x plus y, it is called reactants. That gives rise to xy, that is known as product, that is RHS. Then reactant and product are separated by an arrow. Arrow means this is the symbol of arrow. Then two or more reactants and or products separated by plus sign, anything x plus y. Two or more is there means we can take another plus also. That is known as, like this we have to write with a plus sign. Conditions mentioned on arrow. Condition mentioned on arrow means if we are taking x plus y gives rise to any condition is there, we can write here upon or below the arrow. If we are giving temperature, we have to write. If any catalyst we are using, we have to write here. We will get xy as a product. This is product, these two are reactants. Then fifth one, physical state of the reactants and products to make the reactions more informative. And some of the physical state of the reactants and products to make the reactions more informative means you have to tell that it is a gaseous form or it is in liquid, otherwise it is solid. We have to take that one. And if it is in the gaseous form means gas or liquid or solid, we have to write that also. It is important. An example is given. We will see that one. Magnesium, it is in solid. See here, S is representing solid. Oxygen, that is in the gaseous state, we will use the magnesium oxide. So MgO, that is in the solid state. This is reactant, this is product. I hope you understand. These points are very important when writing the reaction. Concentrate carefully once again. These 5 points are important when you are writing the equations. Once you check properly everything. Balanced chemical equation. Next we are moving to the balanced chemical equation. First one is, one law is there, law of conservation of mass. Mass can be neither be created nor be destroyed. Here you see mass means some anything. We can't create also, we can't destroy also. As a chemical reaction, mass can be neither be created nor destroyed in a chemical reaction. In the chemical reaction only, neither be created nor be destroyed. Any mass, any bulk amount we are taking means we can't create also, we can't destroy also. That is the total mass of the elements present in the products. Here one something we are taken means total mass of the elements present in the product of a chemical reaction has to equal to the total mass of the elements present in the reactants. If the reactants x plus y, that gives rise to product. If product having mass 1 kg means reactants both should be equals to the 1 kg. Both are should be equal. That only we can represent here. 1 kg should be there. Here it is 50. Here we can take 50. So we will get 1 kg. Here also we will get 1 kg. Like this we can tell. This is the law of conservation of mass. Next we are moving next point. The total mass of element in the reactions, that is equal to total mass of the elements and the product. Both A plus B gives rise to AB. Both the masses should be equal. Masses should be equal. It is very important point, law of conservation of mass. In the chemical reaction balancing of the chemical reaction, product and the reactant should be same mass. Then we have to change some of the things in the reactant and in the product also. So that and all we will study in the further classes. I hope you understand till here. Thank you.